So now let's see the algorithm for push, pop and display operations. Okay. So what is meant by push? You are trying to insert elements into the stack. Okay. What did we say? In case if I want to push elements, I need space, right? Only if I have space in the stack, I will be able to insert elements or push elements, right? First, what should I do is start. Okay. Second one is check if top equals to n minus 1. Right? First, I have to check in case if it is full or empty. So if it is full, in case if this condition is true, stack overflow. Right? In case if the top is equals to n minus 1, you can't insert elements into the stack. So it gives a condition called stack overflow. And in case if this is not true, right? So then you can increment top value and store the element some stack of array. In the top value itself, you will be storing, right? Now, stop. Okay, this is how you write the algorithm for push operation. First, what you will see, in case if you want to push elements into stack, first you have to check whether the stack is empty or full. So now the stack is full. So you cannot add elements into stack. So there is a condition called stack overflow. In case if this condition is not true, there is another thing happening. Top equals to plus plus. Right? You have to increment the top. That is what we have did in the example, right? So top plus plus. Now store that particular element in the top value. Okay? So then stop. This is the algorithm for push elements into stack. Next one is pop. First, start. Now, yes, if you want to delete elements, first, what you will check, there should be some elements present in the stack, right? So that is the first condition. Check if top equals to minus 1. In case if this top equals to minus 1, then what should happen? There is a condition called stack underflow, since you cannot delete elements from an empty stack. Okay. So in case if this condition is not true, what you can do? So you have to delete present element stack of top. Okay. Now this element should be deleted and then top value should be decremented. If I try to decrement the top value before itself, it will show me, stack will show me, say for example, my stack is like this. There are elements like this, 0, 1. Okay. Now I try to delete elements. First, say for example, I've written top minus minus. Now top will be without decrement, without deleting value only, I'm writing top equals to 0. Now the element deleted is, this should not happen, right? My third element 3 only should be deleted. Okay. So if I try to do it, if I try to print after incrementing, then it will show me the value which is next to deleted element. Okay. It should not show like that, no. What it should show? It has to show only the first deleted element that represents the top value. Okay. After that, you have to decrement the top value. Right? So, after this, you have deleted, then stop. Okay. This is how you pop elements from the stack. Now I'll explain you how to display elements from the stack. We'll see how to perform the algorithm for display operation. What is meant by display operation? So you have to print all the elements in the stack. So from where you keep printing? From top only. You need not write the elements from 0. You have to write from n minus 1. So what should I do now? First start. Now set I equals to top. Since elements printing should happen from top. Say this is these are my elements. Okay. 0, 1, 2, 3. This is my top right now. Okay. Now I'm trying to print these elements. Now top is I value is 3. Okay. Now next point is repeat till I should be greater than equal to 0. I should start at 3 and end at 0. I value should start from 3 and end till 0. Okay. Now what you'll do? You have to print I value. So print stack of I value. So each time after printing, I have to go downwards. After printing this value, I have to go to here. So to go down like that, you have to decrement top value. Okay. Now we'll see how this is being performed. I equals to top. This is okay. When I is greater than 0, 3 is greater than 0. This is also right. Now print stack of 0. What is stack of? What is stack of top? 4. 3. Then 4 is printed. Now top decremented. So top is 3. Now top is 2. Stack of 2 is equal to 17. Now again top value decremented. Stack of 1 is 15. Now again top value decremented. Stack of 0. Okay. So this happens until only top value is greater than 0. Greater than equal to 0. Because in case if I don't write this condition, it goes up to -1 and I have not inserted any values at -1. So I might get unnecessary values or garbage values. Right? So this is how it is happening.